I don't quite know how I ended up here. Always Mirela asking me, can you do the other slot then? And I'll present something. Microservices and databases and how to do that smart. Introduction, nah, I'm one of the Oracle guys. I'm really proud to have spoken in Russia. Da. Microservices and databases. I have been to Romania, and I took this picture myself. This is on top of the Transalpina. That's the radio station on top there. I think the Transalpina is more beautiful than the Transfagarasan, but every German is on the Transfagarasan. I've been on Transalpina. This is the Transfagarasan for those of you who know where it is and what it looks like. This is looking upwards from the north in the direction of Curta-Darius, if I'm correct. I'm going to talk about microservices, and I know that on online presentations, the agenda is not really an issue. I'll talk about microservices, I'll kick around some ideas, I'll mention a few databases. Double check, can anyone see my mouse running around?
Yeah, yes, I can see.
Yes.
Okay. Yeah.
And you had a very good pronunciation, by the way.
I had a good teacher. I always exercised how to pronounce the other city later. Microservices. There are about two things about microservices that I want you to remember. It's about decoupling pieces of software. It is actually what used to be modular programming. And for those of you who know what the solid principles in object-oriented are, I think they apply. If you've never heard of the solid principles, have a Google. It might help you with microservices. Of course, everybody wants to be Netflix, so microservices are scalable. You can start 100 or more, or 1,000 if you want to. Now, in reality, nobody is Netflix, but still. So we are also totally serverless. If you want that, you can be agile, you can do DevOps, you can run on Kubernetes, on Lambdas, on functions, you can run on demand on a pay-as-you-go cloud. Amazon loves this because you will pay as you go, and you will go, so you will pay. It's very hip and trendy, but a microservice in most cases needs some data. There are very few programs that don't have some sort of state. Something to display, lookup, that's easy, or something to store as a system of record. And that is a bit more complicated because you end up with a point of truth, and you have to know what is my point of truth at the moment. So that's where the database comes peeking around the corner. I like my animations. And this talk will try to link microservices to databases. And I should click a bit more silent. Now here's Vlad Michalcha. A real by-the-book microservice architecture requires a database, maybe even a database per service. And this is a discussion that came up in the Oracle world as well. I owe Frank Pachot, for example, a lot of credit for bouncing around ideas. Most microservices will need some sort of database. And that's where the elephant comes into the room. I wanted to put the Postgres elephant there later. So I have a microservice. In most cases, microservices are a URL and somewhere in the cloud. So you do an HTTPS call to it, either get, post, or put. Probably you will have an application component somewhere, Java, an application server, something that receives your HTTPS request and connects it to a database, maybe do something else with it. You probably have a database store somewhere, and the sequence will be something like you call an app, then the app calls the database does something and returns a value or an error, and you put that back to the user, and hopefully you can avoid 400 and 500 errors. And there's the elephant in the room again. You have been interacting with a database. Now, if you have state in microservices, if you're lucky, you just have to convert Fahrenheit to Celsius to Kelvin or something. And that's easy. You don't need state in that case. It is simple, not very common. Compressing files, for example, sometimes processing video. But if you process something, it probably comes from somewhere. Video comes from a file, and you have to send it somewhere, either to an endpoint or to a file again. There's always interaction with state, mostly. You can have a microservice that is more or less stateless because it has read-only data. Examples are looking up values, looking up zip codes, maybe looking up and displaying images. You need a store, but it's not that crucial. You can read it from a file system, you can read it from a big or a small database, and you display the image, basically. You don't have to store a value or a stock. You're sort of safe. The more dangerous one, the tricky ones, are the stateful microservices. If there is such a thing, you know, zealots will say, oh, microservices are stateless. Yeah, sure, but the data that you store somehow has to go to state. Probably need ACID. Base is only so good. You know, base is the basic available, soft state, and eventually consistent. I always have to think about it. Now, I prefer my databases to be ACID, atomic, consistent, isolated, and dependable. You will need a data store, probably a database. If you do stock keeping, you don't want to miss a stock, and you don't want to promise someone a gadget and then discover, oh, I'm out of stock, it's on back order, that sort of thing. You need updates, you need serialization, you need reliability, basically. So you got three types of microservices, in my opinion. The ones that don't require any data, the ones that have data, but it's fine. You can read it, you can distribute it, it doesn't have to be timeliness, and the ones that seriously need to store data. There we go. Keep this in mind. Of course, there's always the elephant in the room, database. If you have that standalone microservice, you could convert Celsius to Kelvin, do some fancy string document formatting. You could compress a file, for example. That's fine. That's calculation. You don't need to consult a database. You don't need to connect to other components. Your component is the perfect microservice. It runs isolated, and it can scale up to 1,000 and doesn't have to connect to any data. Often kind of small program, ideally to containerize. Everyone will shout Kubernetes, yay, lambdas, whatever. You can deploy, you can scale out on any platform, you can kick it into any cloud, it'll run. If this is your challenge, you're lucky you. You have a microservice situation. You are totally buzzword compliant. You probably have something like a calculator in that case. I'm kind of making it ridiculous, but a calculator would be one of these things, you know. It doesn't need any data. Somebody types in numbers, out comes a result. That's ideal to scale. That's a typical microservice, is a calculator. It scales, no problem. And then you get the second situation, you need data. So you have a microservice and there is a data store somewhere close to it or behind it. You might do something like zip code lookups, address validations. You can run a catalog with images and information about products you want to sell, mostly static. Your choices can now be, you either include your data set in the microservice, and that means your microservice becomes a bit bigger, becomes slightly less easy to transport and to start. Your container grows, so to speak. Or you can call out to fetch the data. And that means your microservice gets a request, a GET, for example, an HTTP GET, and it says, oh, I need to look up somebody's address, and it has to go to the database with addresses, query that database, and return the value. So you could try to include your data in the microservice. That way the data will age with the microservice. That service runs forever. If it runs for 100 days, your data is 100 days old. And if you include it in the service, that service becomes a fat service. It becomes slightly slower at startup. It requires more memory to run. It becomes more sluggish. You know, I know people who put a complete Oracle XE database in a Docker container. It's fine. And in some cases, I could even recommend it, but it does become a fairly fat microservice and really slow in startup scaling. If you do the call out to fetch, to find, to go search for your data, you need an additional effort. You're going to spend time calling out in order of milliseconds, probably tens of milliseconds, and you cause chattiness over your network. And wherever you have to find that data, all your microservices come together at the place where the data is stored. And that might be your bottleneck as well. A database can only handle so many connections. A database runs on something with CPUs. It can generally run on an 8 CPU system. You can run 7 database queries simultaneously, and then you have 1 CPU left for the overhead. Well, that's about it. It's a bottleneck. Your microservice becomes coupled, and that was something you didn't want. Remember, it's not quite autonomous anymore. So you end up with a database somewhere behind it, and lines, links, are actually network calls most of the time, to and from your database, to and from your microservice. Do you want that? Maybe. If you have it, keep it in mind. You're going to have to consider this in your design and deployment, because if you create 1,000 of those microservices, you end up with 1,000 lines into the database, and something's going to melt. Now, probably your database, not your server, not the hardware, but you never know. There was a fire in France, and it would be interesting to find out if it was an overkill of microservices. No, just kidding. So this was the second case. You have a more or less stateless microservice, but you have data, readable data. You need data. You can either include it or you can fetch it when you need it. And there are pros and cons to both. You can have a stateful service, and then effectively your service equals your database. Think about it. If to keep your data, you have a single point of truth or a system of record, like order taking, stock keeping, payments, airline reservations is the example everybody always wants. Is it reliable? Yeah, maybe. You have a limited choice because you need something like an asset storage. So you'd have to think about how much can I afford to lose? What capacity do I have to design for? Because even if you scale out, there will be a limit somewhere to what you can do. You know, I'd be very curious to see how things like RoOUG and Gigabyte handle sort of infinite capacity. Would be a good test. But under normal circumstances, you connect to a database, you have a bottleneck somewhere. You'd have to think about your response time. How many milliseconds can you tolerate before you give the return? And you may want to think about error handling. Do you have a fail whale to elegantly say, you know, we're currently oversubscribed, please come back later. Your get call is important to us, and you know, we'll do anything in our power to service you as fast as possible. That sort of thing. But you need a database. So here is your challenge. This is where all the database technologies come in. Database going through hoops. Now, I'm an engineer by formation. I was sort of mechanical agricultural engineer. I used to build machines. We have a few ideas from engineering. Like, for example, we would like to minimize our components. The less components, the better, because we don't have to look after too many components. You know, one server is easier to maintain than 25 pods in Kubernetes, sort of. But if you do need more components, maybe you want to limit the number of different components and just use identical components. I remember the Deux Chevaux from Citroën. You could disassemble that with it had 4 sizes of bolts. So you needed 4 tools to disassemble the whole car. Ideal, you know. In IT and database land, you want to minimize your number of microservices. I think you still want to. You know, if you need 1,000 microservices deployed somewhere to service your user base, you either have a lot of users or you have a sort of inefficient design, in my opinion. You probably want to use a database. If you use one database, you end up with a monolith. So there's your biggest risk straight away. If you want to use the same database for all microservices, like Vlad said, every microservice might require a separate database. It's quite possible. If you connect all your microservices to one database, you end up with the monolith, the bottleneck again. So microservices and databases are an engineering challenge. And you'd have to read up on things like, how can I do this as simple as possible? Can I use the solid principles in my approach? You know, what choices do I have? It's a design thing, and you want something that is solid, that's a pun on the word, and easy to maintain, and you know, not break too quickly. You may want a bit of a Dacia, indestructible Romanian engineering. You could go over the Transfagarasan before it was hip with that car. Yeah. That's the kind of decent, solid engineering you want. Now you go to microservices, and the concept was, you know, there's the database. We need to do something of decoupling, and we want it to be scalable. So we wanted to stand alone wherever possible, and we wanted to start fast and start many and scale up, scale out if we can. Can we fit our data in a container or in a microservice? Well, if you have your data included in code, like all the zip codes from Romania or all the zip codes from the UK, you can fit those in a large comma-separated file. You could fit them in an array if you need to. You could also choose to go with something called SQLite, which is still a SQL database, but it's meant to go in devices like phones. You can compile it into your program. You can include it in your Java development. You can bring it out as a separate component into your container. But your data is in tables, and you can query. So you can join the tables, you can create views, and you can create stored functions in SQLite even. You could choose to integrate Postgres in your microservice. Postgres is only megabytes in size, not gigabytes like Oracle, still lightweight. Postgres goes fine into a container. And with Postgres, you can choose whether you connect to your data on a remote volume or just include it in the container. That works either way. You could choose to include Oracle XE. I think Vlad has that in his development environment. That's a fairly fat component. Your microservice becomes a lot bigger, something in the order of 2 GB minimum. And that makes it a bit sluggish to deploy. I am going to argue in the rest of the presentation that you should do something like bring your code to the data rather than the data to the code. And I will introduce the smart DB as well. But it remains your design, your choice, your design. You see, this is what I would do. I would, in some cases, take the microservice, turn it into a stored procedure, and store it in a database. And that way I reduce from 2 components back to 1. But you may not like the fact that a database does all that work, and you may think the database becomes rather complicated, and you are correct in a way. There's 2 keywords that I'd like you to remember, and they are database related. Remember something called smart DB. We've introduced that the word or the concept of smart database, smart DB, by bringing code to the data rather than data to code. You could do as much as possible in SQL. You can use views to link data together, to pre-join your data. You can use stored procedures to do a lot of your work if you choose to do so. You can do your work inside the database and close to the data. You don't have round trips, you don't have chattiness. You can have a single call into a data component and bring back your results probably in something like 10 milliseconds. If you have a microservice that needs to go to a database with like 20, 30, or 100 calls, you lose time on your network, you load your network, and you're processing both ends of those calls all the time, so you effectively burn a lot more CPU as well. But that's a different topic. Just remember, smart DB means you put your code in the database. And here's the other one, converged DB. This is what Vlad talked about when he put JSON in the database. In a modern database, Postgres, Oracle, and even in SQLite, you can put not just tables, you can put JSON objects in. You can put documents in JSON or XML or any format. You can process geographical data. You can do GraphQL queries in your database. You can outsource that work to what you used to call the database component. And yes, it is a bit of a monolith. So keep it in mind and beware of the monolith. And this is how This is stolen from Oracle, of course. I need to thank Maria for the graphic. If you do that, you convert your database, you literally kick all those components into the database, and there you go. Keep it in mind. So we go back to that read-only data. For a microservice that just has to serve out data, so pre-coded data, images, code list, lookup values, I will argue you should use a database. You should put a smart database inside or very close to your microservice. You can use SQLite, that fits everywhere. You can use Postgres. You can use PL SQL, which is the Oracle procedural language that still fits in a large container. And there are components called Postgres or Oracle REST Data Service, ORDS. If you want any Google stuff out of this presentation, Google that line, ORDS and Postgres. And yes, they fit in a container. Basically, you are working to reduce your calls to and from components. You're working to reduce context switches, to reduce load. There you go, Google. There's your homework for the day. And if you do that, if you create a microservice with a database attached to it, read-only data, more or less, you can fairly easily deploy, multiply, create multiple instances of the server, as long as the database isn't in the multi-gigabyte, terabyte size. Maybe. So here's a poll time. And we'll skip this one, but if there was a live audience, you know, next year when I come to Romania, I will poll you guys with a raise of hands. Like, do you like SQLite? Do you avoid SQLite? Or do you, what's SQLite? So Mirella, maybe collect some replies in the chat, but you either give it a thumbs up, you say, oh, over my dead body, or you go, what's SQLite? If you're in the what SQLite category, you know, don't be ashamed, but Google it. So here's the recap. We had the 3 types of microservices. We have state, no state, that was easy. Translate from Celsius to Kelvin. We had the lookup data. You can choose, include the data or connect to a database. And we have the ACID database that needs a proper data store. That's the biggie. So here we go. How would you do that? Well, of course, my recommendation is build a smart DB anyway. You know, put a database behind your microservices. And you can't put a complete ACID database in every microservice because they need to synchronize with one another. Try to reduce your calls as much as you can. And start thinking straight away, because this is microservice. This can scale out to 500 lambdas. And then you get this call like nothing's moving anymore. We have a hang-up. Do you have locks in the database? So no, I think you hit max processes. Doesn't anyone say max processes anywhere? No. And that's what happens when you have a scale out microservice attacking a database. Be careful. So from the start, think about what you do to prevent overload on a database. And again, you know, use those concepts. Stored procedures are probably the most efficient way to mix and match and process your data. So do that, but it's still your choice. If you're a Java guru or a Python adept and you want to store things just in a flat table and don't use views, don't use joins, don't use PL SQL, don't use stored procedures, that's fine. That's a valid choice as well, and I respect that completely. But if you put stuff in your database isn't just a DevOps, you know, a break often component anymore. Your database becomes not just a swarm or cattle. Your database becomes your pet. You'd have to take very careful care of it. In a picture, and this is built from a whiteboarding session at a customer a couple of years ago, you know, you can have the standalone microservice, and that's fine. You see, there is no connection to the database at all. And this will scale forever. You know, you can have 1,000 of these and nobody breaks a sweat. You can have your read-only subsets of data. And I would still argue you need smart DBs. You need to integrate your database with your microservice, have them close, and you need a regular sort of data replica system. Whenever you start up a microservice, make sure you get a fresh copy of whatever data subset you need. You know, there is a line going from your master source to your microservice. And then, of course, you have your asset processing microservices. They are hard linked into the database. They do inserts, they do logs, they do commits, they do transactions. And you should consider coding as much as you can in PL SQL or in the procedural language of your database. The closer to that database you code your processing, the less work the whole stack has to do. And in the long run, it's probably better maintainable. It'll definitely scale better. But again, this is my opinion. You have to choose. There's a couple of loose ends. You can see those logos here already. If you have that read-only database, you could put logic in your database, joins and code and PL SQL. You probably need a database. And if you distribute sets of data, you're effectively using CQRS, the command query response, I think it is, the one from Martin Fowler and Greg Young. It's a known pattern, so to speak. So you're still hype and buzzword and hip compliant. If you use an asset data store, I told you before, make sure you have some sort of overload, safety valve, limit the connections of the pool size. You have systems where every microservice has a Java pool deployed and it starts up 50 connections. That microservice runs in a place where it has one CPU. It can only use one connection anyway at a time, but it opens 50 because that's what the pool size was. And you can, what do I need to do with 1,000 connections? I've only got 20 microservices running. So protect against that overload if you can. And then, of course, everyone is afraid of the monolith. And there are a few systems out there now that we call new SQL. I think this is what I want to talk about next year. But there is Yugabyte and Cockroach DB. And again, I would do a poll, show of hands. Anyone using Cockroach? You get the eager nerd go, yes, we do, and we have 1,000 connections to it. Same thing with Yugabyte. Those are databases that are still asset compliant. They are serializable. They have proper locking mechanism. But they scale on a cluster. So there's always, under Yugabyte, there are always at least 3 servers or 3 containers serving the database. And they work on the basis of a quorum. They determine who has the point of truth at a particular point in time. And they should scale, theoretically, and I'm quite interested, they should scale beyond what a normal monolith can do. The logo of Yugabyte is a rocket circling the Earth, so it's quite ambitious there. But again, if you use a database, from day one, start monitoring it, do your instrumentation, check your log files, measure usage, how many connections, how many transactions, what is my trend, what happens if I have 20, 30, 40, 50 containers running, can it handle that? Do you know and can you confirm that it runs within the design spec? Can it actually handle 100 containers, or would it break at 50? Or can it maybe, without a problem, scale to 200 containers? Could be. You'd be surprised what a database can do if you do proper calls to it. Yeah. So by now, you guys know what my main message is. Normally, as a consultant, I would ask you for your watch and then tell you the time, which is 10 minutes to 2. But when state is important, you have to consider processing close to your data. And I'll come back to that a couple of more times. You have to minimize your calls, reduce chattiness, make sure things scale. You have to simplify your maintenance. If you have less components, that's better. If you have identical components, that's favorable. If you can apply those engineering concepts of building a really simple car to your database, that's good. I would recommend you look into stored procedures and call the stored procedures by a very light, thin application layer. ORDS, Postgres, any Java calling a stored procedure is probably a good design concept. And you will have some sort of monolith. You'll have a database with a single point of truth. So mitigate the problems, throttle whatever comes in there, prevent overload. Consider those read copies with CQRS as well. And here is the main message. Everybody knows Obelix from Asterix, from the comic books. And he was a big guy because he fell into that magic potion thing. He can carry that rock. You know, he's carrying the boulder, the dolmen, whatever it is. He can do that. But I can't lift that thing. So when I want to work with it, I need to bring my tools to the rock rather than the rock to the tools. And this is the analogy of a good database. You know, don't carry your data to your tools. Carry your tools to your data, because your tools will always be lighter than a fair-sized database. Now, most databases nowadays run way above gigabytes. Just about everyone has a terabyte data somewhere in their organization. You cannot move a terabyte to your processing unit. You can move your processing to the terabyte. That is the lesson. The smart DB, the converge DB, the bring code to data hashtag, you know, that's what I want you to remember. Tonight, tomorrow, I want you guys to remember obelisks carrying around that rock. You know, it is much more clever to carry your tools to the rock than to drag around the rock. There you go. Maybe I should put a cylinder database on the back of the guy. So we have interesting times ahead because things are always developing. I'm really curious to see how this is going with the microservices. One of my guesses is microservices will become so big and fat that they actually become small or proper containers or small servers, actually. I'm also curious to see what's going to happen with the new SQL. You know, can we really design and build a supersized database that can just span the earth and everyone connects to it? You know, imagine having a single connect string for your whole company. Everyone connects with the same connect endpoint. Interesting. There's a lot of new systems coming up. I'm curious. Normally, I would say, see me over coffee to discuss, see what comes up. You know, tell me what you're interested in. You know, next year you go sit here and tell me what you think. Don't take my word for it. Always Google and read the manual. In case of doubt, when in doubt, simplify. That's why my blog is called Simple Oracle DBA. If you used to be that if you Google the 3 words Simple Oracle DBA, you'd hit my blog post. But nowadays people buy the AdWords, and then I sort of sunk to the 5th place in the ranking. You know, if you go to Yandex in Russia, it still works. Simple Oracle DBA on yandex.ru. You can find me. I'll see you guys there. Twitter handle, the German poet, always obligatory German reference. Goethe, he said something like, the limitation shows the master. Meaning, you know, you can only be a master of something if you can also do it simple. So there we are. Questions, experience. This is the moment where you can shoot me. I'm going to hand control back to the masters in Romania. Yeah. How do I?
Thank you, Piet.
Yep.
So please open your microphone and shoot Piet. he invite us to shoot him.
Yeah, I don't do that. I'm not doing that again. I forgot to switch on my lights, by the way. Yeah.
No, it's okay. We are seeing you. So question. Thank you.
In the chat?
No, on the chat for the moment, I'm not seeing anything.
Are we? How are we? I'm too quick, too early. Yeah. See,
yes. Yes.
I need people in the room so that I can, you know, raise hands. Everyone using SQLite, that sort of thing.
So no one, no question.
Is it dinner time over there?
Not really.
Okay. I'd be interested to see the evaluation. No questions at all is never a good sign. So please send me the review remarks.
So if people use SQLite, which basically, I remember a presentation from the creator of it, and he said that SQLite is a database that actually aims to be a replacement for writing to a file, actually. So it's something like a wrapper to writing eventually to a file. But if they would do that for microservices, yeah, writing to it would be easy, but then how would they share the data between?
I think the business case for SQLite is to include it in the service.
Yes.
SQLite is meant to be part of your program. You can compile it into a C program. You can ship it out with your Java application component. I think that's the ideal business case for SQLite. And the advantage of having SQLite is that you can pop your normalized table data in it. You can just copy your tables from part of your tables from Postgres and Oracle into SQLite and distribute it out. And instead of connecting to your Postgres database with a connect string over a network with latency, you connect to your SQLite, which is in the same component, container, service as your code is.
Yeah, but it's great for offline mode, but eventually when you want to reintegrate the data, that's when it's going to become very
correct. That's correct. If you save data into SQLite, you have an additional job of replicating it back to your master.
Yeah. Yes.
Not that I would try to avoid. So strictly for read only or distribute only data.
Okay, makes sense.
If your price list only changes every day, you can maybe afford to include it in a SQLite.
So I'm not sure if nowadays people really use microservices like that. I think that most of the time they're doing microservices, but they are still using just one database, and maybe some of them probably use different schemas or something like that too. But I think that most of them I don't even do that. So I remember clients who basically just write to different tables. So that's the only difference.
I agree. And in my experience, at some point they might overload or melt down the central, the monolith database because they connect too many services to a single database. And then they go, see, it's a monolith. It doesn't scale.
But I think they use most of the time they use connection pooling anyway. They just have to figure out the right connection pool, the right pool size for, and that's the problem is that if they also do horizontal scaling, eventually they will still run out of connections because you cannot.
Yes, the other example I gave is if you deploy Java components by default, they tend to come with a default pool size at startup of 10 or 50. So they just open 10 connections to whatever the connect string is. But most microservices run in a unit that has a single CPU. It can only run one process at a time anyway. So you probably don't need the whole pool. You need one or two connections. And when they realize that, their microservices become a lot better scalable and sizable and deployable. But I say that as a database person.
But why would it run in a unit that only has one CPU? You mean in the cloud, which is restricted only to one core to run the microservice?
Or in a Kubernetes pod.
Okay, so it's restricted by the configuration. Okay.
Yeah.
Then of course, it doesn't make sense.
I know the Microsoft functions and Amazon Lambdas are similar. They are effectively single process.
But actually, you made a very good observation because most people who use Java, they use Spring Boot, and they use. I bet that they use the default. Most of the time, they use the default configuration for Hikari, which uses 50 connections.
Yes, I know.
So I can bet that this problem it's a problem that everyone will discover in the end.
Yeah. Yes, and we try to warn them about. Yeah.
It's a problem they didn't bump into yet.
Correct. And it is this. There are similar items out in IT land for people who want to switch to what they call document stores. They put items on a bucket, and all they have is the key to the document. And they are suddenly retreating to the hierarchical data model. Everything is in the document. And that's fine. Yeah, go ahead.
Pete, there is a question in the chat window. Can you see it?
An
From
advice
Albert.
to how to design or implement an orchestrated Saga pattern using SQL. You got me there. It is quite possible that I already have a database that is using a Saga pattern, but I need to Google what a Saga pattern is.
It's Saga pattern is when you're you basically when you're booking an airline ticket, a ticket for flight, and then you also want for one car insurance, and also you want to reserve a hotel room, and everything goes to different data stores. And when you change your mind, you have to roll forward and to tell them that. So you commit. It's not isolated, but then when you change your mind, you have to compensate for the actions you did.
That is tricky. You need to choose either pessimistic or optimistic locking. And if you have different data stores, you'll end up with data retrieved from different stores. You decide to do the purchase. You have to go out to 5 different databases, and they have to come back all with a success. And if one of them fails, everything else needs to roll back. That is the story of the old two-phased commit. It's effectively a two-phase commit, what you build then. I don't have a reference for that. I would probably choose optimistic locking as a base, as something that I would put in my design. Optimistic locking, so when you do the transaction, you verify, am I still on version 75? And if somebody else has updated the record, I have to fail, or I have to try and book another car. That's one. The other is there will be a benefit if the asset part or the transactional part is at least in the same database and under the control of a single connection, because that way that connection is the only one that needs to do a commit. Yeah. So it's not simple, and I don't have a complete answer to it. But whether you do this with SQL or stored procedures, or whether you do it with microservices that control their own separate database, I think the problem remains. I think the challenge is more or less the same, whether you use or one single transaction or one single monolith. Someone can always steal your seat or your car effectively. Am I right in that? Or didn't I quite get the Saga thing? So this is where you ask the guy who asked the question, did it answer your question? And then he will say something like, yeah, but not completely. Yeah.
Well, he can open his microphone and say it. If he's still, let me check if he's, yeah, he's still here.
Okay.
So, yeah. Any other question? If, yeah. No, Mike.
Yeah.
Thanks for your response.
I know that problem. Yeah.
Yeah.
I probably have a huge echo, right? Yeah.
So if there are no other questions, we will close the evening and event right now. Thank you again so much for presenting here. Take care, stay healthy, so we will be able to meet in person next year in Cluj. I decided, meanwhile, that we will go to Cluj.
Yes, please. Yes.
Thanks for organizing it.
Yeah, sure, my pleasure. So